but often doesn't or can't. Where do the systematic, predictable errors, the biases, come into play?
They come directly from System 1's reliance on those mental shortcuts. The heuristics I mentioned. Heuristics are incredibly useful. Right? They let us function quickly without constantly grinding System 2 calculations for every little thing.
Sure, shortcut good.
But they're perfect. Because they're shortcuts, they sometimes lead us systematically away from logic or probability or objective fact. These systematic deviations are the biases. Think of them as like predictable bugs in the software of our fast thinking. Recognizing these biases is really key to understanding where intuition might lead us astray.
Okay, let's talk about these famous biases. The halo effect, that's a classic, isn't it?
Absolutely. The halo effect is a perfect example of how System 1 creates this coherent, potentially misleading overall impression. It's a tendency for your judgment of one characteristic, say, someone's attractiveness or confidence, to spill over and influence your judgment of other unrelated characteristics.
So if someone looks good, you assume they're smart too.
Basically, yes. If you meet someone who's, say, handsome, speaks confidently and cleanly, System 1 instantly forms a positive overall impression, a positive halo. This halo then biases how you evaluate their other traits, even if you have zero evidence. You might assume their ideas are brilliant, their arguments sound, just because they made a good first impression.
You even anticipate others will be swayed.
Right. Source material mentions anticipating that an audience will judge the content of a handsome and confident speaker's comments more favorably than it actually deserves, simply because of that positive halo. System 1 fills in the gaps to make the picture consistent.
Wow. Okay, another big one is the availability heuristic.
Availability, yes.
That's about how easily things pop into your head. If you can think of examples easily, I assume it's more
Well,
common.
exactly that. The availability heuristic means we judge how frequent or probable something is based on how easily instances or associations come to mind. Things that are vivid, maybe emotionally charged, recently happened, or heavily reported in the media that are easy to recall, and so they feel more common or more likely than they might statistically be.
The keyword example is great for this.
In a brilliant demonstration, people are asked, are there more words in English that start with the letter K, or more words that have K as a third letter?
Okay, starting with K, kitchen, kangaroo, keep, easy. Third letter, acknowledge, ask, bake. That's harder.
Right. It's much easier to search your memory for words starting with K. It takes more mental effort to scan for words with K in a third position. Because words starting with K are more readily available in memory, people overwhelmingly guess they're more frequent. But for several letters, including K, L, and R, and B, they're actually more common in the third position. The ease of retrieval biases, the frequency judgment.
And this must have huge effects on how we perceive risks, right? Things that get reported a lot seem riskier.
Huge implications. Think about judging, say, the risk of plane crashes versus car crashes. Plane crashes are rare, but when they happen, they get massive, vivid media coverage. They become very available in memory. Car crashes are far more common, but reported dramatically. So people often overestimate the risk of flying relative to driving.
Or the example about politicians versus other professions.
Exactly. Judging frequency of, say, scandals among politicians compared to lawyers or doctors. Politician scandals are often front-page news, highly available, so we might get an inflated impression of their frequency compared to other groups simply because the reporting is so available, not necessarily because the underlying rate is higher.
And this can spiral into availability cascades.
Right. A availability cascade is like chain reaction. A relatively minor event gets media attention that sparks public fear or outrage because it's now easily recalled and emotionally resonant. This public reaction then fuels more media coverage, which makes it even more available, escalating fear, often way out of proportion to the actual statistical risk.
Like the love canal example.
And love canal is often used as an example. While it certainly raised important environmental concerns, the intense media focus and resulting public fear, driven by vivid images, arguably led to a disproportionate allocation of resources, specifically to the type of toxic waste cleanup relative to other, perhaps statistically larger environmental or health risks. The ocean availability overwhelmed statistical reality for a while.
Or the LR here with apples.
Another classic case discussed by risk perception expert Paul Slovic, a TV segment highlighted a potential possibly low cancer risk from LR on apples, used very vivid, emotionally charged imagery. This created enormous public fear and pressure, leading to chemical being pulled, even though many scientific assessments suggest the actual risk was very small. System 1 reacts strongly to the available, vivid, scary story, and System 2 often does step in effectively with the statistical context.
A powerful effect. Okay, let's move to another major one, the representativeness heuristic. This is typed with stereotypes and ignoring base rates.
Representativeness is absolutely fundamental. It's System 1 judging probability based on similarity. How well does this specific case match my mental stereotype or prototype of a category?
Like the Steve, the librarian example.
The quintessential example, you get a description of Steve, meek and tidy soul, the order and structure, passion for detail. Then you ask, is Steve more likely to be farmer, salesman, pilot, librarian, or physician?
And instantly you think librarian. It just fits the description perfectly.
Exactly. System 1 sees the match between the description and the librarian stereotype. It feels highly representative. This judgment completely ignores the base rate. In fact, there are vastly more farmers or salesmen in the population than librarians.
So statistically, he's more likely to be a farmer, even with that description.
Much more likely, just based on sheer numbers. A truly rational judgment would combine the representativeness, how well the description fits, with the base rate, how common each profession is. But System 1 latches on to the compelling individual description, the stereotype match, and System 2 often just goes along with it, neglecting the crucial base rate information.
And the Linda problem is the ultimate demonstration of this, right? The conjunction fallacy.
Oh, the Linda problem is famous for a reason. It beautifully exposes this conflict between representativeness and pure logic. You get a description of Linda. 31, single, outspoken, bright, majored in philosophy, concerned with social justice, anti-nuclear activist.
Okay, paints a picture.
Right, then you're asked, which is more probable? A, Linda is a bank teller. Or B, Linda is a bank teller and is active in the feminist movement.
And B just feels so much more likely. It fits the description perfectly. It tells a coherent story.
It absolutely does. It's far more representative of the description, but logically it cannot be more probable. Why? Because the group of feminist bank tellers is entirely contained within the larger group of bank tellers.
Right. Logically, every feminist bank teller is a bank teller.
Exactly. So the probability of being just a bank teller must be higher than, or at best equal to, the probability of being both a bank teller and a feminist. It's a basic rule of probability. But System 1's preference for the representative, coherent story is so strong that it overrides logic for most people.
Even when you point out the logic, people resist it.
Often, yes. The common reaction mentioned in the source is something like, so what? I wasn't thinking about probability, I was thinking about which one sounded more like her. They prioritize plausibility or representativeness over logical probability. It shows how deeply ingrained this heuristic is. System 1 suggests the intuitive, representative answer, and System 2 often fails to correct it, either through laziness or just not spotting the logical connection clearly.
This neglect of base rates seems pervasive. Does how the base rate is presented matter?
Hugely. It turns out we're much better at using base rates if they're presented as causal stories rather than just abstract statistics. The cab problem illustrates this well.
Remind me of that one.
You're told about a hit-and-run accident involving a taxi at night. Say 85% of taxis in the city are green, 15% are blue. A witness identified the cab as blue. But the court tested the witness's reliability under similar conditions and found they correctly identified the color 80% of the time, but got it wrong 20% of the time. What's the probability the cab involved was actually blue?
Okay, my intuition focuses on the witness being 80% right.
Right. Most people focus on the witness reliability and largely ignore the base rate, that only 15% of cabs are blue. But if you reframe the base rate causally, for example, saying, although the two companies operate equal numbers of cabs, green cabs are involved in 85% of accidents. People are much better at integrating the base rate information. System 1 loves causal stories. Abstract statistics, not so much.
And we also ignore sample size with representativeness.
Yes, System 1 is surprisingly insensitive to sample size. It focuses on the proportion or the intensity of the evidence, not how statistically reliable that evidence is. The urn problem is a good example.
Okay, lay it on me.
Imagine